Let's talk about how to debug software. Here I have a little Python Django application, and what it's supposed to do is it's supposed to contact Stripe, and it's supposed to calculate an average of all the transactions from the current months. So here I have some test data, and I have one transaction of 200 euros. So what I expect it to do is I expect it to output me 200 as an average of that transaction for the current months. And here we have a little Django application that has an endpoint that if you contact it, it's going to return you that information. So let's just test it to see if it works. So I'm going to launch the Django server. It started here. I'm going to go to that server, and now I'm going to go to, well, this route that it prompts me also, and that's the route that is going to do the operations that I just described. And now what do we see here? We see that the average transactions value is 0. Is that something that we expect? Well, not really, because we have here a transaction of 200 euros, so we expect 200 euros. Now the question is, why does it happen? Where did we make a mistake? And here is where the problem of debugging comes in, because if you look at Django, it's a beast. It's a large framework, right? So it's when you run it, many things happen. And what you really want is you want to debug only the part of the application that is responsible for generating the erroneous behavior. Now, we're not here interested in the entire Django. We're not here interested in anything that it does. We're only interested in the business logic that causes the erroneous behavior, which is described over here. And this chunk of code is a chunk that is responsible for request handling. I'll make it a bit larger. So this chunk of code is the code that is responsible for request handling. So what I'm going to show you now is how to debug this chunk of code line by line. Alright, we are not going to run the entire Django server, we are just going to see what goes wrong in this line. And to do that, we're going to shut down the Django server, and then we are going to I'm going to point to the line that I'm interested in, and then I'm going to click Shift Enter. So I click Shift Enter, and here I see that VS Code creates this interactive sheet for me, and there it evaluates the lines that I pointed to. And then if I go to the console, here you see this line, I type total amount, and you see that it evaluates this Python expression, it evaluates it to 0. I can type whatever I want in this console and evaluate Python expression, like 2 plus 2, for example, it says 4. The same way I just evaluated this variable, and if I write some non-existent variable like foo, I evaluate that, it says name error, so it didn't find it, so this shows us that total amount was evaluated correctly. Alright, now the idea is that now I'm going to step through this request handler, step through each and every line of it and see what happens on each and every line, and see if what happens corresponds to what I expect to happen, right? But first of all, I'll tell you how to install this extension so that you have it, because that's not available by default in VS Code. You need to enable it. And to enable it, you need to go to extensions, and you need to install this Jupyter extension. So you need to search for Jupyter and find the extension and then enable it. And once you have installed and enabled it, you need to go to the settings. In the settings, you need to search for Jupyter execute. And here you see that it finds the option execute selection, and make sure this option is checked, and that should enable you this functionality. Alright, now I'm going to do what I said, this technique of line-wise debugging. So first of all, to do that properly, I need to evaluate all the imports. and that's because the code relies on those imports. If I do not bring them in scope, the code is not going to be executed properly. So I'm going to set up to execute these setup instructions. So those two lines get evaluated. We see them here. If I click here, you see that the chunk of code that got executed. Next, we have the current month that gets evaluated. So we're trying to calculate the transactions for the current month. So that's what happens here. We're evaluating what the current month is. And if I write current month, I'm going to get 10. So it's October, and that's correct. I'm filming this video in October. And now what we have next is this loop. And what the loop is supposed to do is, well, it uses the Stripe API. By the way, I forgot here to evaluate the Stripe API key. So if I evaluate this instruction, it will try to contact Stripe, and it'll probably fail. So if I do that, you see that it says no API key provided. So I need to fix that. I need to go here and evaluate this line that sets up the Stripe API key, and it reads it from the environment variable. And then this instruction is going to be evaluated correctly. So notice how I can just select not the entire line, but a part of the line, and shift enter, and it's going to be executed all the same, right? And now notice what gets returned over here in this console. So what gets returned is an object, and it has the data field, and the data field is a list, and it's an empty list. Now that's clearly not the right behavior. So why exactly that happened? Well, I mean, let's take a look at this line that got executed, and we see that it's calling the Stripe API, stripe.charge.list, and here it's calling it with the created parameter, and the created parameter looks very much like a filter. So what the created parameter does, it filters by the created field, and it says that the created field must be greater than or equal. That's what this GTE stands for, and it is greater than or equal to the timestamp that is returned here by this datetime field. So the datetime field has this, it evaluates the current year, the current months that we have just evaluated, and 1 here stands for the first day of that month. Then it takes the timestamp, and then it converts that to an integer that is supplied to the created field. All right. So our assumption is that the filter does something wrong, right? Because we have this complicated expression. So let's try to simplify it. Let's see if the simpler version of this expression works. All right. So we had a list with a filter, but these are two things going on here: a list and a filter. Okay, so let's test them separately. Let's test if list works. So what we're going to do is we're going to copy this expression for the list and try to call it without any filter whatsoever. So we call that, and what we receive is some data, right? We receive a data that is not empty, and that's what we expect to happen from the first try, from this call over here with the filter. So clearly something is wrong with the filter. Well, what exactly is wrong? Let's try to debug that. Well, the filter is concerned with the date time, with the date of the transaction creation. So let's try to obtain the date from the transaction, from the first transaction of this data. So what we do is we can rerun this list over here. We can assign it to all transactions, and then this we can just test if it's correct. All transactions appears to be correct, so it has this data field, so let's obtain that. So all transactions.data, evaluate that. So it gives us an array. Let's get the first element of that array over here. And that gives us the, this JSON of the transaction. Okay, now we are concerned with created field. So let's access that. So created. And then it gives us the timestamp. Then we can use date time to own this timestamp. Okay, so it doesn't gives us that, so it's not the right way to call it. Also, you see, it's also good to test your code like that, because here I assumed that I can call date time with this integer and it will work. It will create me a date time object, but it's not working. It's not the right way to convert a timestamp to a date time. So if I look it up, it's probably going to be date time from timestamp, and I do it again, and now it works. You see that from timestamp works, and here I get the date time in the format of the year, the month, the day, and also the hour, minute, and second data. Alright, so far so good. Maybe I'm going to save it into the created variable so that we have this data over here. And now let's take a step back and see what we've done here so far. So we had a chunk of code that didn't work, and what we are doing with it is we are stepping through it interactively. So first of all, we isolated it. We have isolated it from the entire Django logic, from the entire framework that's going on. It's like really important that you isolate your code, isolate your code that produces the errors, unexpected behavior from your entire application, because if you don't do that, you're dealing with the entire application, and it's not good. It's too much complexity. And if I did that, if I pinpointed that to just this script, I dramatically reduce my complexity, because I'm only working with those like dozen lines of code, right? I'm not dealing with Django anymore. I'm just those lines of code, right? But even that is not the end of the story, right? Because I am stepping in like line by line. So this is one line that I executed, this is one line that I executed, this is one line that I executed, right? But now I'm encountering a loop, and the easiest thing to do is to execute the entire loop. But that's not exactly what we are going to do. Not exactly the right thing to do, because loop itself is a complicated entity, right? There is a lot of stuff going on in the loop. If your code, if your list here returned like 1,000 entries, you will have like 1,000 iterations of this loop. And it's like too much context to deal with, too much context to debug, too much context to get the intuition for. So what we are doing next is we are stepping through each iteration of this loop, right? I know it might sound tedious, I know that it might sound like too much work, but it's really worth it, because you really pinpoint individual pieces of logic. And if you pinpoint individual pieces of logic, you can work with them, right? You do not need to second guess. You do not need to assume what this loop did, because assumptions, they very frequently are wrong and very frequently are the main source of your troubles. The filtering condition says that this date must be greater or equal than this date. So what is this date? Okay, let's evaluate this date. Current month date time, so we will store it in a variable. We will evaluate that variable. It's timestamp. I mean, maybe I do not want this timestamp. Maybe I want it without the timestamp, because I cannot read this number. I want it in a human readable format. So I'll reevaluate it without the timestamp. And then I see that the current month is, well, it's 1st of October 2023, right? And the 0 hours, 0 minutes. Okay, so far so good. Now let's see why exactly the filter failed, right? So we take this, what was the filter? We take what was the filter, and the filter was that the current, that the creation time, which is this one, must be greater than or equal than the current month date time, which is this. So what is the creation time? Well, it is 16th of August, and the current month is 1st of October. Now, is this greater or equal than this? Well, the answer is no. So that's exactly why this program fails. Now you see how we used the stepwise debugging, the line-by-line debugging, to isolate the problem and, well, to pinpoint the exact cause of the problem. The exact cause of the problem is that our test data is outdated. It's a little bit old. Okay, so maybe what we want to do next is to extend this little API over here to be able to accept the month parameter that would basically tell it from which months to count, right? So let's maybe here say current month equals to request get, so it will be a get request and it will have the month parameter. And if this month parameter is not present, only then we say that we default to the current month. So far so good. Okay, so next let's test the application. Let's test whether the fix works. So to do that, I'll need a terminal. This is my terminal. I'm going to fold my screen back. Going to run the server again. And now we should be able to use this month parameter in the request. So if I say months and 8, in theory it should work. And now I'm getting an error. So in practice it didn't work. Now what exactly happened? So whenever the error happens, first thing you need to do is to figure out on which line exactly it happened. So you see, you get first a bunch of lines outputted, and that's in any Python application, by the way, not necessarily Django. The first thing you do when you get those errors, you look at the lines of the stack frames, the files of the stack frames. So here is a file where the error happened, and you check if it is your file, if you have control over that file. And the answer is no, because it comes from the Django library. You see, it's Django core handlers, blah blah blah. So what you want to find is the file that you actually have control over. So this file you don't have control over, this file you don't, this file you don't, this file you don't. They're all Django files. This file, it's your API views.py file, and you absolutely have control over it because this is this file. It points you to the line where the error happened, which is line 27. Line 27 is this. So apparently something is wrong with the date time thing, with the filter. And let's see what the error says now. So now we have pinpointed the error where it happened, on which line. So now let's see what exactly went wrong. And we see here at the so we found the name of the error, the message of the error, and it says type error, and it says type string object cannot be interpreted as an integer. And well, what can be possibly here of type string? What has changed from the previous execution? Well, we have changed the value of current month, right? Because that's the only thing that we edited in code. So what happens here is get over here, the get parameter, it's not an integer, it's a string, because when making an HTTP request, an HTTP GET request, you're allowed to pass any string as a GET parameter. So what I want to do here is to convert it to an integer so that our application doesn't complain. So I write int, and let's see if it solves the problem. So I update it, I refresh it, and it appears that the problem is solved because first of all we don't have the error, and second we have the expected value for the average transaction, which is 200 euros. It's apparently 200 euros in cents, so that's why we get 20,000 here. That's how Stripe outputs its values. And that's how you debug the Python programs. That's how you debug really complicated environments. So the temptation might really be to just debug the entire program of in its entirety, right? The temptation might be to make some assumptions what goes wrong in code and try to act on those assumptions. Like, for example, oh, maybe I have the Stripe key that is not correct. That's why it doesn't return me any data. So if you have if you do not specify the months, you get this value 0, and you might be like, okay, maybe my key is incorrect. And then you're going to Stripe back and start debugging that, for example. Or you might be like, okay, maybe Django is not properly replying to me. Maybe something is wrong with Django. And the problem with those assumptions is that they are not grounded on anything, on any evidence. What they're grounded in is you basically having the entire bulky application, and that application not behaving the way you intended to behave, and you having in mind all those things that could go wrong with that application. And you're picking one of them and making that as a working theory and starting to act on that. While that kind of works, it's ineffective, inefficient, because the application is bulky, there is a lot of code. So what you really want to do is, first thing you do is you minimize the code that caused you troubles, right? So if this is the code that was responsible for that 0, well, you want to be working only with this code, and you want to completely isolate yourself from the rest of your application, from the rest of Django. And moreover, even the chunk of code here is not that trivial, right? Because you have a loop here, and many things can go in the loop. So what you really want is you want a precision execution of code, right? You want to be able to point to a single expression, a single line of code, and you want to be able to execute just that. And that's exactly where the Jupyter extension comes in play, and that's exactly where this option that allows you to send it to the interactive window, to send the code into the interactive window, that's exactly where it comes into play. So you do that, you break your code into as small chunks as possible. If you face a loop, for example, you evaluate sub conditions of the loop. Like you see, it's like I can evaluate everything in this loop, right? This sub expression, date, time, now, year, for example. I can evaluate that. I don't need the entire expression. Well, it says name error because I didn't import it, so I'll need to import it as previously. But the point I'm trying to make is that you have such a fine-tuned control, such a fine-grained control over what you execute. It's not even the lines that you execute. It's expressions that you can execute. You can highlight the code, you can shift enter, and it's going to be executed. You can see your code here, right? And you can even introduce those introduce variables in code. So for example, if I am debugging this part of the for loop, the single iteration, I try to step into it, like total amount, blah. It relies on a charge, and a charge comes from the iteration of the loop, right? So what do I do then? I do not want to execute the entire loop, because I mean the entire loop is heavy in setup. I need to set up this thing over here, the array that it iterates on. I need to set up the charge. So what I can do is I can actually simulate the charge as a variable, right? What I can do is, for example, make a new class for the charge, like class dummy charge, for example, and then I can say that in its initializer, what I'm going to do is self amount equals to 10, for example. So, and this will give me like charge like this, right? And then if I do the pointwise execution of charge amount, it gives me 10, and now I can step into this loop, right? I can do total amount plus equals to charge amount. I can do total amount, and it will be 10. And I can do the same with total transactions plus equals 1. Well, total transactions not defined, no problem. I can define it by evaluating this line, and I can continue execution from this line. So now it's total transactions plus equals 1. I can inspect the state. Total amount is 10. Total transactions is 1. And now I can execute this line to calculate the average. So you see how powerful it is. It's this ability to execute the lines one by one, to execute expressions one by one, to execute sub-expressions. Like if this went wrong, I could just point to like, what is total amount? Okay, it's 10. What is total transactions? Well, it's 1. What is the result of their division? Well, it's 10. And well, that's basically how you can break down your program, how you can decompose it, how you can debug it, expression by expression, line by line. And at first it might seem very tedious to do it line by line, expression by expression, but it really works well for you to develop this intuition. You can do it like 5 times. 5 times you do it like in your program, line by line, expression by expression. You'll spend a lot of time, but you'll gain a great intuition on how your program works, and next time you will have a better sense on which expression might contribute, which might not contribute. Alright, so that's what I wanted to share with you today, and yeah, happy coding, happy debugging, and see you in the next videos.